All right, 10 a.m. Everybody ready? Awesome. Good morning, Calgary. Hopefully I can get a thumbs up if you can see me and or hear me. Does anybody want to move closer? It's up to you. All right, I'm just waiting for confirmation from Calgary that everything's going. Hopefully they realize they're supposed to tune in this morning. It's still buffering. Oh, yeah, it can take up to a minute, I guess. All right, sorry. They're not seeing the stream, it's just buffering. Excellent. All right, we're good to go. Okay. Good morning, Calgary. Good morning, Vancouver. Week 3, day 3. That's where we're at today. Today we're going to talk about HTTP, cookies, and user authentication. I want to preface this with, I'm not a security expert, and nobody really expects you to be security experts either. There's just some best practices that we follow as devs, and I'm going to outline them here. And then as long as you follow those, then you won't get into trouble. Cool? Awesome. Okay, so here we go. So let's talk for a second about HTTP. You had a whole lecture last Wednesday about it. HTTP is a stateless protocol. So what does that mean? What does it mean that HTTP is stateless? Anything? Is assessed in a vacuum. To use? Yeah, there we go. Vacuum. I like that. That's a good answer. So essentially, the server is not required to preserve any record of previous transactions. Previous, let's say, requests. So your server is stateless, or the HTTP protocol anyway is stateless, which means that it doesn't preserve any state in between any requests. When you send another request to the server, it's as if you're totally new to the server. The server doesn't know you from a hole in the ground. You could have sent 100 requests before now. The server still has no idea who you are. Okay? So that presents us with some challenges, right? The server doesn't remember us. If we had consistent sessions, then we could say log in, and then we wouldn't have to authenticate ourselves every single time we go to a page, every single time we visit some website somewhere. But because of the fact that it doesn't preserve any state, it doesn't know who we are the next time we come by, every single time we have to re-authenticate. Some previous lectures have given the example of, like, if you go to a nightclub. I don't go to nightclubs. So I'm going to say, like, what's that place with the Chuck E. Cheese? Okay, when you go to Chuck E. Cheese, say that, I don't know what you were expecting to come out of my mouth, but it probably wasn't Chuck E. Cheese. Okay, so when you go to Chuck E. Cheese, they put like a stamp on your hand. This isn't really going to track, but let's pretend that it does. Okay, so you go in there, They validate that you're with your particular kid or whatever. Maybe you go to Chuck E. Cheese as a grown-up. That's totally cool. I'm not judging. And so you get a stamp on your hand. It actually probably works better as a club. Okay, let's pretend I know what I'm talking about and I go to nightclubs all the time. You can tell from my attire, I go to nightclubs all the time. Okay, so I've been told that when you get there, the bouncer has to check your ID, right? And because you're only allowed in the club if you're over a certain age, right? Presumably. So as a quick reminder that they've already checked you, they might stamp your hand or something, right? And then if you have to go outside for a smoke or a vape or whatever, and then you've got to get back in, you don't have to go through that authentication process again. You don't have to show them your driver's license and everything. You just say, hey, I was already here. I've got the stamp, right? And then they just let you breeze right through. So what do we have that's kind of similar to that in that we were exploring yesterday? Cookies, absolutely. So cookies help us to solve the stateless problem. I'll put problem in quotes because the designers actually chose to make HTTP a stateless protocol because it helps out in various other ways. But let's call it a problem for right now, because our problem is we want users to be able to log in and not have to log in every single request. You don't want to have them send over their username and password every time they make a new blog post or something like that, right? Okay, so you delved into cookies yesterday. So what is a cookie? You played with them a tiny bit yesterday, right? You were setting cookies and retrieving cookies. Anybody? What is a cookie? It's the stamp on your hand. Awesome. Fantastic. It's the stamp. Great. Moving on. No, a cookie is a small text file that's stored where? In the browser. Exactly. In the client's browser. There we go. They are obviously key value pairs, right? Yesterday you were setting up your user ID and you were giving it a key and then a value, and then when you were getting it back again, you were requesting that key and you got back the value, right? We're used to key value pairs inside of objects, right? Cool. Okay. So we've got our stateless protocol. We've got cookies that kind of help us go along. So what were we using the cookies to do yesterday? I know they were the stamp, but what in particular? You didn't actually get to the point of logging in anybody, did you? Did you? Right, okay. So Vancouver's telling me that you could log in and it would follow you around the site. Awesome. So I think, why don't we switch over to trying to log a user in? So I set up a server, and I'll go over it really quickly. The point of this lecture is authentication, so we're going to focus on that. So I just scaffolded out a little simple, like login and registration form. Styled by a professional, I might add. Okay. So this should look pretty simple. We're bringing in Express, obviously. This lecture is going to be more like a conversation about like cookies and user authentication and security best practices. So if anything jumps out to you, if you're unclear about anything from yesterday, and this goes for Calgary as well, just jump in and ask a question, okay? Because we're going to essentially be going over the stuff you did yesterday as an opportunity for you to ask any questions, get any clarity you need. Cool. Okay, so we bring in Express because we want an Express server. We bring in Morgan because I like it for logging. We're probably going to be accepting post requests and cookies. So we bring in the body parser and the cookie parser, right? Initialize our Express app. I set a port to 1234. It doesn't have to be, you probably know this already, but there's actually 65,536 open ports on your device per internet connection, okay? So you typically do something like 8080 or 8000. Does anybody know why we use 8080, 8000, and 3000 at Lighthouse or just in general? That's correct. So the answer for Calgary was it's because of how the Vagrant machine is set up. Only certain ports are forwarded. And I believe you have 3 ports, 3000, 8000, and 8080. 5 ports. Okay. Awesome. So, but if you're running natively on your own or you're running a web server somewhere in the cloud, you're going to have 65,000 ports you can listen on. Okay. So I just arbitrarily chose 1, 2, 3, 4. Cool. This should look decently familiar to everybody. It's our user database, because we're not going to talk about databases for 2 more weeks. So this is our user database. It's an object filled with objects. So I just threw in some example ones so we could practice logging in. Random key, alphanumeric key, email, and the most secure password in the world. Every programmer uses this password. Okay. And then another key to identify the user, an email, and a password. Okay. You can probably guess what we're going to do with these later. Cool. Okay. Now we get to our app use. The way I like to structure my files is I like to put all of my statements together. So like all of my app uses together, all of my app sets together, all of my gets, all of my posts, structure them all together. Okay. It just helps me keep organized. So we set up our logger. Has everybody used loggers? Has anybody seen someone use a logger? Maybe? Garrett didn't use a logger yesterday? Cool. Okay, awesome. So we're going to take a look at loggers today as well. Body parser URL encoded. Does anybody know what extended false means? Or what does URL encoded mean? Should talk about this yesterday. You did? Okay, cool. So that total silence was not lack of knowledge. It was overwhelming knowledge. It was like, move on, please. Okay. I'm going to assume that everyone knows what that is, and we're just going to move down. Sure, yeah. I'll just go over it. For the record, for if people are watching it in the future, they might not know. Okay. So there's various different ways that we can encode information to be sent over the internet, right? So with typically with the default value for an HTML form is URL encoded. And what that means is, let's just say we've got a form with a username and a password field. Let's go with email and a password field. Okay, so the default way that forms are encoded is URL encoded. And what that means is it turns your key value pairs into something that could be sent over the internet in the URL. URLs are only strings, they only allow certain special characters, and they don't allow spaces, right? Have you ever typed in a domain name and included a space? No, right? Because they're not valid characters. So, let's take so what would happen is when it gets encoded, we would get something like, and so we have our form with our email and our password, and what HTML does is it packages it up on submit into key value pairs that are separated by an ampersand. What do these look like? Has anyone experimented with query string parameters? Where you have your example.com, maybe you wanted resource number 1, and then you see the question mark. And then you could pass along extra information. Maybe you're like, lang equals English, because that's what you want. So everything after this question mark is a query string parameter, and you'll notice that it takes the form of key equals value, no spaces, ampersand, key equals value, key equals value, key equals value. And things like a space become like %20 or plus, depending on how it's encoded, right? Cool. Okay. So what we're saying is when we receive post requests, Express, when you're setting things up and populating the body object for us, what's coming in is going to be URL encoded. If we were expecting JSON, we would say this was JSON. If we were expecting, what are the other options for body parser? URL encoded, raw. Those are the most popular ones. Does everybody know after the update? Yes.
So if you have a site that takes different types of code, you just change the body parsers using it like post request, for example?
Or you could set it up, you can probably set up multiple encodings, so it'll process it. You might be able to construct new body parsers, or you might just be able to list these over and over and over. Generally, your APIs will only be, for Calgary, the question was, let's say you've got an API that takes JSON and URL encoded data and raw values. I believe that you can actually just stack these on top of each other. I think you can say app.use, app.use, app.use. And I think Express is smart enough. I'm not sure though, because the majority of, we'd have to experiment with it, but the majority of APIs that you set up, you're going to be planning them out to begin with. And you're going to say, what does my API return? Or what is it expecting as the body? Are we going to be sending JSON back and forth? Are we going to be sending URL encoded? Is it going to be raw values? Are they going to be CSVs? Like, what are we going to get? Okay. Cool. No questions so far. So that's the URL encoded part. We're saying that's how our bodies are going to come in. So this is how you parse that request. So it turns this into rec.body, which will be an object with email user@example.com. And password is 1234. Obviously, that's going to object. There we go. So we can make reference to it like this inside of our app, right? Which we're going to do very shortly. Cool. So we told Express how to parse the body. Extended false means, do we want to include any special data structures in here? Are we going to be sending over full objects? Are we going to be sending arrays of values? By saying false, I'm saying we're just going to get primitives. Everything's going to just be a key value pair where it's a number, maybe it's an integer, maybe it's a string, something like that. Very simple, so don't worry about it. If you were expecting more complex values, just turn this to true, and then you can actually send over arrays and things like that, and the body parser will know how to deal with that. Cool. Then we bring in the cookie parser. Yes. Mm-hmm. For Calgary, the question was, where does this email come from in the body, right? Where does the key come from? And this is actually defined inside of your HTML form. It's from the attribute on the input. And in particular, it is the name attribute. Okay, you can set ID, you can set all those other things. Those are for CSS. Those are for jQuery, which you'll learn about next week. Those are for DOM manipulation. If you want it to show up in the body, give it a name. Okay. Then HTML knows how to package it up and turn it into this URL encoded string. And then the body parser knows what to do from there. Do we need to bring in a body parser? Do we need to bring in a cookie parser? Remember, I don't ask trick questions. I'm just wondering if this is something that we need to do. Only if we're using them. That's an excellent answer. The answer that I always give for every single package that you use in Node, in the JavaScript environment, is no. Every single package that we bring in is written in JavaScript. So we could absolutely parse the body ourselves. Look at the HTTP request. We could look in the header and pull the cookies off ourselves. But that's a lot of work. It's a lot of code. And somebody, well, better than me, maybe not better than you, but better than me, has written better code. So we might as well just use their code, right? Why reinvent the wheel? I probably said this because I say it all the time, but that saying of we stand on the shoulders of giants so we can see further, that's so true in tech. We don't really invent anything new. We just cobble already existing things together into some new shape and we go, ha! It's more like building with Lego. You don't actually make your own Legos, unless some of you did. No, okay. I made my own Pogs. Does that date me? Okay, there we go. I got one, yeah. Awesome. But yeah, we don't actually need to bring in any of these packages. They're just JavaScript. They're just JavaScript libraries that we're bringing in. But they make our jobs a heck of a lot easier. We can have a full server running in less than 50 lines of code because we bring in a package. Okay, cool. So where were we? Any more questions about this? I wanted to point something out which is super cool about the IDE. I think it's super cool anyway. So with this latest update to VS Code, remember your IDE is your friend. You're going to spend 8 to 10 hours a day in here at least 5 days a week for the foreseeable future. Okay. So VS Code now, besides showing you all of the valid props and methods that are on an object, they've starred the most frequently used ones. So if you have something like a rec object that has a whole bunch of different props on it, the most frequently used ones will be at the top. So you can just go, oh yeah, URL encoded, that's the one I wanted, rather than having to scroll through the list. Cool. That's my symbol for scroll. Okay. Awesome. Then, since I want to include some CSS styling, I need to serve that up. So I'm actually going to serve the public directory. And inside of there, we just have a simple style sheet. We'll go over this code in a second. I mean, you'll be doing CSS next week. Essentially, I'm just making this look pretty. Cool. But we need to be able to... Where was I? There I was. Okay. But we need to be able to get that out to the users. We're going to use EJS templates. So we're rendering the HTML, but how do we associate the CSS with that? We can't send along our server-side rendering renders an HTML page based on our template and our template vars, right? It puts them together like a game of Mad Libs, fills in all the blanks, and then spits out an HTML page to the user. But if we want to style that, we need to publicly expose. Express.static means this is just a static folder, nothing in it's going to change. If you want something in it, hit /public and you've got it. Okay, so we're just saying anybody who comes by, they can look inside this public directory, they can retrieve these files if they want. And that's how I'll show you in the EJS how we're pulling the CSS in. Cool. Moving on. We need to tell Express what our template engine is, right? This should be pretty familiar by now. View engine EJS. And this tells Express by default to look in which folder? Views folder, exactly, for our templates. Cool. Save that. And then we're moving down here. I have an app.get login, which renders a login. One for register. And then has anyone used the wildcard before? Yeah. Cool. Okay, I got one hand up. Awesome. So you talked about this yesterday with Garrett, no doubt. But these paths, these routes are matched from the top of the file to the bottom of the file. Literally what Express will say is, I've got a GET request. Here's the endpoint. Does it match this? Nope. Okay, moving down. Does it match this? Nope. And then it will keep going down. And what we usually do is we have some kind of like catch-all at the end saying, if it didn't match anything else, match it against this wildcard. So this will catch every single GET request. You could type in absolute gibberish into the endpoint, and this is still going to catch it. Okay? You could, in our case, we're going to render the user logged in page, our protected page. Yes, because what is user authentication without something to protect, right? But normally you would do something like 404, page not found, something like that, right? Because if you don't handle this, what shows up in the screen? Cannot post /login, cannot get /whatever, right? And that you don't want your users to see that you didn't set up your server to handle that, right? So I'm just saying here, our goal is going to be to publicly expose these two and protect this protected route, every other route until our users are authenticated, okay? Then we set up our app to listen on the port that we passed in, 1234, and then we have our console log inside of, you guessed it, callback function. Cool. So we can get our server running with node server cookie. There we go. App is listening. Let's kill that. How is the font size in the terminal? Good. Any questions, Calgary? Nope. Still doing good. App is listening on 1234. And if I visit /login, we get our login screen. We go to the register screen. We have a register page. If I try to visit anything else, ooh, I get an error. Did you see that you've seen this error before? Okay, cool. So what kind of error is this? Yeah, I'm not looking for a type. What is this error trying to tell us? Sorry? We haven't defined user yet inside of our template, right? Our template, our protected endpoint, is looking for some variable that we haven't passed to it yet. Cool. Okay, so we've got our login and our register screen. We'll very quickly take a look at those. So the login screen is just typical HTML, right? I always use if we say that this is HTML, there we go. I've probably shown you this already, but you can just use a scaffold to very quickly build out an HTML5 page, right? Which is great because I can never remember these meta things. I used to have to look them up all the time or have a file that I just copy and pasted from, okay? But it scaffolds it out for us. Don't save. Awesome. Okay, so that's the head. Pretty much all I'm doing is setting up the title, and I'm bringing in our style sheet. Okay, so I'm saying, here's our styles. It's in styles.s.css. I'm used to writing Sass, so usually SCSS. Styles.css, and our browser will look inside the public folder, pull that out, and use it to style the page. Cool. So that's it for the head. Now we look at the body. I've got a div just to gather everything together. This is the way that I usually deal with positioning things, is I put everything I want into a container, and then I move that around the page, and then you can move those things inside their box. Okay? You'll go way more into depth CSS next week. Okay, so we've got our welcome. We have our anchor tag, which has an href to the register page so that we can follow our register link. Cool. And then we have a form. So our form has a method, post. We want to make a post request to where? Our action /login. And here's we have our label, our input. So the label for this maps to the ID, right? That's how it knows. This is for screen readers. Does anybody talk to you about this? Why you use the for in here? It's so that visually we can say to a user, yeah, I understand. Email is above this one. They must be associated with that field. But if you were using an assistive device or something, or you're having it read to you, it might not be evident what field, like what value is supposed to go into this. So by saying for email and tying it to this ID, it says this label here is associated with this input. Okay. There's our name attribute that you always want to remember to put in there. And then required. And what does required do? Yeah, you have to put something in. Otherwise, it won't work. See? And I didn't have to write any JavaScript. I didn't have to do anything else. I just put required there. Remember when I said this was the best time to be a web dev? It really is. So I threw in required there, so at least you have to put in some kind of email. And, oh, yeah, required on the password as well. Okay, so this one is type email, so it will actually also do error checking for us. If I just say A, it says, hey, that's not a valid email address. Isn't that sick? I think that's pretty sick. You can specify types for other inputs. Like you could say that this is going to be a number type, and it will actually give you one of those incremental counters. And it will make sure that people can only put numbers in there. And then you can give it a minimum and a maximum value. There's all kinds of things you can do with these types. Okay? So not everything is going to be type text, type text, type text. Okay. So what does type password do for us? Yeah. That's exactly right. It looks just like that. You can type in and it's obscured just in case anybody's looking over your shoulder or something. Interestingly, have you know those sites where you can tick it to show the password, right? Do you know how they do that? They dynamically change the type to text. And then it's raw, and then you can actually see it on the screen. That's all they do, is just grab this input and change its type, and then you can see it output. So there we go. So we got our password. Again, name password, so we know how to access it inside of our rec.body. And then we have a login button here down the bottom. And what's important about this button? What will make this button send this form? Submit. That's right. Type equals submit. If this is type equals button, and you probably came across this yesterday, well, let's see what happens. I'll refresh. A@a.com, AAA, log in. Absolutely nothing, because we told it this is just a button. This is not a submit button. It's just a plain old button on the page. Maybe it does something else. Maybe it doesn't do anything. HTML says, I'm just going to ignore that then. By saying this is the submit inside of this form, it means that when you click this button, you submit the form. What's interesting is with HTML forms, we also get enter submission. Because how many times when you type in your username and password somewhere, do you actually click login? You don't usually, right? You just hit enter. Yeah. So we also get that for free as well with HTML forms. It will auto submit whenever somebody presses enter. Like if I'm in here and I press enter to try and submit the form. Oh, we got to refresh. There we go. Did I change that back to submit? Yeah. Okay. So I can say a@a.com and throw in a password and press enter, and the form's submitted. That's an interesting error. We'll deal with that in a second. And that's pretty much it for login. And as you can imagine, I did our favorite thing, keeping things wet, write everything twice. I copied and pasted login, and I changed login to registered. But same thing, name, email, name, password. Interestingly, I think it's interesting. If you don't interrupt me, I just go on tangents. This is what happens. What do you usually see in the wild when you have a user, when you register somewhere? What do they usually get you to do? Type your password twice. And why do they do that? That's right. That's exactly right. So for Calgary, the answer was, so you don't register with a typo in your password. If you only had one crack at this, how many times do you type your password incorrectly in a day? Right? And so imagine the frustration of, I can't see what's there. Did I type it right? Did I not type it right? Am I typing it right now? So as long as you have these confirmation, so whenever you design a form or something, throw a password confirmation on there. Okay? Okay, cool. So we're moving through. Same thing. We have a form. This one makes a post request to /register. So if I say a@a.com, we're going to see a familiar cannot post. Cool. And then, yes. Do we have to make the name and ID? We do not. Okay, so you can do anything you want inside of here. Sorry? Yes. The for attribute, this string, whatever this is, has to match this ID so that these two match up. Okay? And if you wanted to apply a class or something, if you were styling it or grabbing it with jQuery, I keep saying that, but you're going to have fun next week. It's going to be great. If you're already having fun now, it's going to be even more fun next week. I hear Max laughing over there. So we have our type, obviously, and then our name can be, again, whatever we want. Those are our fields that we define. Okay? But none of these two have to be the same, but they don't have to match with this. And if we had a class on here as well, it could be whatever we want. Okay? We're in charge of this. This is our code that we're writing. There you go. Any other questions about this? I guess I should change this back to email just for clarity. That's a good question though, because sometimes when you look at somebody's code, it's often struggle to say, like, what can I change and what can't I change? What had to be there and what did they define, right? So that was an excellent question to say, do these have to be the same? Awesome. Any other questions about those before I show you our protected page? Nothing? Good? Awesome. Okay, here's our protected page. Again, same thing, title, linked, and a bunch of meta. tags in the head, and then our body. Protected secrets, and some kind of GIF or GIF. I say GIF. Cool. And then here's that line that was erroring out on us. You were logged in as user.email. Remember we tried to visit, no. Really anything else? And it said, hey, you were logged in as user.email, user's not defined. Cool. And then down the bottom here, we have a logout button that I've wrapped inside of a form that has makes a post request to /logout. I spoke with some of you yesterday while I was mentoring about why we would want to wrap this in a form. Why would I not just do something like a href equals /logout? Why wouldn't I just do something like that? And then we just have, because I'm not sending along any data. There's nothing else in this form. It's just a submit button that makes a post request to /logout. So why wouldn't I just write my server to make a GET request, and then I can just set up an anchor tag and have somebody just click it, and then boom, server gets a request, user's logged out. Sorry? We can use this to update the cookies, is what you're thinking, or something like that. Well, we'd have a app.get to /logout and then a callback, right? Or we'd have, I realize those aren't comments in HTML, or we have app.post to /logout and there's some kind of callback. But these could be the exact same callback. The functionality is exactly the same. We can clear the cookies, we can log the user out, we could update a database, we can do whatever we want. Why would we do this instead of this? Specifically for logging out, when we're not sending any other information along. We're not even sending a user ID. We're not doing anything. We're just saying, here's a form, it makes a post request, and there's a button that submits this form. So one of the thoughts in Vancouver is that cookies could be used after you're logged in or something like that, or after you log out, you might be able to utilize that cookie. Let's think about let's move away from like user authentication and everything to very specifically, what does GET mean? GET means read. Exactly. You probably talked about either bread or crud yesterday. So it's either the browse and read, or it's the read. Yeah. Yeah. I don't usually do crud. I teach bread. So yes. So anytime we make a GET request, we're saying, give me back some information. We're saying, give me back all the users. Show me all the tiny URLs, right? Show me something. Give me back a value. But if we made a GET request to /logout, we're not actually requesting anything. We're requesting that the server do something. We're requesting that the server update the state in some way, right? In this case, it's going to be to clear the cookie, but maybe it would also have to clear a session in the database, or set your last time. You know, when you log into terminal or you log into some forum or something, and it says, hey, the last time you logged in was 2014, and you're like, whoa, it's been a while. So this would be misleading if we said make a GET request and then update the state. Okay, so this is why we wrap it inside of a post request, because anytime we expect to change the state of the application, even if it's just a user status logged in or logged out, make a post request. Okay, so but unfortunately, the only way right now that you know of to make a post request from the browser is a form. Okay, anchor tags, image tags, links, scripts, those all make GET requests. Okay, so this is our only option. That's why we wrap it in a form. Okay, so unfortunately, not loading yet, so we can't see what this GIF is. Oh, I'm so excited. It's going to be amazing. Okay, so let's get to the point where we can log somebody in. So I think that's pretty much the state of our application. The CSS is extremely bare bones. Yeah, I think we're good to go. Okay, so we need to, so the idea is that we don't have to edit any of our views or any of our CSS. We're purely going to write server code to authenticate users. Oh, and let's take a look at, I'll get rid of this error. I also wanted to talk to you about Morgan and what Morgan does. Where are we? Nope, up. There we go. App is listening on 1, 2, 3, 4, and we're going to go to /login. Okay. Visited login screen. That's great. Really? Again? Okay. Don't do this to me. There we go. And refresh. Oh, you're super annoying me right now. Okay, we'll look at Morgan later. Somebody remind me when we're not getting this massive error in the terminal. Apparently, actually, you know what I'll do is I will comment that out. Cool. I really want to show Morgan. Okay. Let's do this again. Refresh. Hey! Cool. Okay, we go to the register page and hey! Something's happening in our application. Something happened. Users are clicking around. They're making requests to our server. They're doing all kinds of stuff. And we have absolutely nothing coming back from our server. We can't look at the terminal and say, my God, he's killing him. You know, we can't do any of that stuff. Okay, cool. At least, hey, somebody got the reference. Cool. So what does our logger do? You could probably guess. Let's, oh, we were already including Morgan. It was down here. There we go. App.useMorgan. And let's start our server back up. And then I'm going to make a GET request to /register. What did that do? We have logs now. So that's literally what this does. You know that Express uses middleware, right? It's unopinionated, which means it doesn't tell us how to use it. It's the reference that I really like, or the analogy that I like, is, did I tell you this? I can't remember. I give so many lectures. Express is like the Infinity Gauntlet. Okay? That either hits or it misses. Okay. So, and middleware is like Infinity Stones. Yes, exactly. So we can build up our Infinity Gauntlet to do whatever we want it to do when you snap, right? We want to start a web server, right? We could probably do other things. So this is all just middleware. And what does middleware do? It sits between the request and the response. Okay? It gets a shot at those objects before we do or after we do. So what Morgan does is it steps in and it says, hey, every single time you get a request, I'm just going to go in, get the pertinent information for you, and console log it for you as a helper method, so that we don't have to go into here and say, console log someone went to /login, console log someone visited /register. And we can see they made a GET request to /register. They got a 304. Can anybody guess what the 304 is about? Maybe I can, sorry? It's a response code, exactly. So let's take a look at HTTP cats. Has anyone gone to HTTP cats? Okay, this is awesome. By the way, there's an HTTP dogs. It's much more raw. Cats is very SFW. Okay, so here's all of our cats. Let's take a look at 304. Ooh, not modified. From generation to generation, not modified. So what this is saying is it's telling our browser, since the last time you visited this page, that the page that you have cached already hasn't changed, so just use that one instead. It's a way of making our pages load more quickly. So since we didn't update register in any way, shape, or form, that file didn't change, our server just said, use the one you've already got. You already refreshed this page. So why did I get a 200 now when I refreshed? Because I did a hard refresh. I did on Macs, it's Command-Shift-R. I think it's something to do with F5 on Windows machines. And that said, I don't care what's in my cache. I want you to hit the server and get stuff back. And when you start dealing with CSS, you may have to do that because you'll make changes, but your server is just going to say 304, 304, keep using the same styles you've already got. Nothing new here. And you're going to say, why isn't it being applied? Just do a hard refresh. Command-Shift-R, and then you're guaranteed to get 200s from the server. Okay? So we see that we got a 200 in response to register, and we got a 200 in response to our styles. So everything's loading. That's great. What is this request for? The little icon in the tab, exactly right. That little icon up there. So as a helper, every single time your browser connects to a new web server, it says, hey, give me your fav icon. Maybe it's a little cat. Can you see that? Maybe it's a little cat. Maybe it's like the GitHub Octocat. Maybe it's the compass. Right? I'm assuming that's a compass. Okay. So as a helper, your browser is making this request. It says, also give me your fav icon. And we didn't have anything to return for that request. So it's actually just using the default Chrome icon, which is a little globe. Okay? It could just have to do with the fact that I'm running from localhost and it has a previous one cached already. Would be what I would hazard a guess at. Usually you do see this error out as a 404. I'm not sure why it's not right now. And it might simply be because, like I said, everything I do is off of localhost, so it might just say like, okay, I had one the last time, so I'll just use that one instead. Cool. So if you actually wanted to have a fav icon, you would just put that in like your public folder. And there's icon generators online, and we're allowed to use animated icons now. Okay. Cool. So, where were we? I got so caught up in the fav icon. Okay, so this is Morgan, named after Dexter Morgan. And they actually say in the documentation here. Where is it? There it is. Named after Dexter, a show you should not watch until completion. So, I didn't watch the last season. I'm assuming it didn't end very well. Okay, cool. So I'm just going to pretend that it ended great. And I'll leave it at that. Cool. So I think we're pretty much caught up. Okay, so the first thing we need to deal with, let's just leave this for right now so that we have something we're trying to protect. We need to satisfy the ability to log in. If I take one of our users and I take Andy at 4321.ca and I plug that in, and then PASSWORD and press enter, cannot post to login. So what's our first step? What do we need to do? We need to write a route for that post request, right? So I'm going to put it above our catch-all route just so we don't get any weird stuff down here. App.post, we're going to make a post request, receive a post request. We're listening for a post request to /login, right? And it takes a callback function. Rec and res. Do I have to call this rec and res? No. Does everyone agree? No? Okay, cool. We can absolutely call this A and B. We can call it request and response. This is our callback function, and no matter what we call these, even if we omit these, it's still going, Express is still going to call our callback with the request and the response object, even if we're not listening to it, even if we just say, I'm only interested in the request, or I'm going to call my request hello, and I'm going to say hello.body. A little weird, and you won't see that in your docs anywhere. You're going to see rec or request, but you absolutely can. These are our variables. We're in charge of these. Okay? Rec and res. Okay, so now we've got our listener set up. What do we want to do with our request that's coming through? Should we take a look at it? That's what happens when you don't look down at all while you're typing. Rec.body. That sounds good, right? Let's take a look at that. So we're going to console log the body. We'll restart our server. Cool. And we're going to not send another post request. We're going to do it from here. PASSWORD. Submit. Yes. I see the finger moving around. Yeah, absolutely. Why is this just idling here? We sent no response. HTTP is a call and response, right? So your browser doesn't know. Your browser knows that we got our server. The browser knows we got the request was good to the server. It didn't say cannot post to slash. It matched a route. It didn't get back an error message. But we didn't send back anything else. So it's just waiting. It's like you're waiting on customer service and you're just do. Oh, I don't want to hum too long after, Nima got us banned from YouTube. So no copyrighted humming. Okay, so yeah, absolutely. And when will this finish up? Right. Well, ultimately, we are going to compare the user and the password and do some operation. But the only way this is going to stop is it gets a response from the server or timeout. Yes, exactly. Your browser has a set amount of time that it will wait for a request to come back before it says, you're just not going to get back to me. Okay. And you can customize that. You can customize it for your API. You can customize it for requests from your browser. How long do you want to wait to timeout? Cool. Okay, so let's see what showed up in our console. I think I'm going to turn off the protected again, just for right now, so that we don't get all that garbage in the console. Okay, start up again. App is listening. Go back. PASSWRD. There we go. I think I typed it right. And we got some kind of object printed out to the console that has an email with what I typed in and a password of password. Awesome. Any surprises there of what was inside of the body? Cool. Okay. So we know that we can get the email from rec.body.email, and we know that we can get the password from rec.body.password. But what is rec.body? We just console logged it. What is this? It's an object. So we can use ES6 destructuring on it. We could actually say, give me back email and password from rec.body. We're saying, give us back these props off of this object and store them in variables with these names. Okay. You can also alias this if you wanted by doing something like that. This would be the equivalent of const user email equals rec.body.email if you have collision somewhere or if you want to be more specific about what it is. But typically, we'll just carry over that name. Okay? Everybody good with ES6 destructuring? Cool. Okay. We have an email address and a password. What do we do now to log a user in? There's our users object. What's our next step? So check if the email and the password match a user in the database, right? So our first step is going to be to look in our database and see if there is a user with that email address, right? So what are our options for that? We're going to have to iterate over this object, right? There's really nothing else we can do. Later on, when we have access to the key, we'll be able to just randomly access it and just say, give me back this user object, give me back that user object. But without that, if we're just going to look through here, we're going to have to use some kind of iteration, right? We're just going to have to loop over it. So how are we going to loop over the keys in an object? We could make a function. We could explicitly make a function. Normally, the way that I work, normally the way that I work is I write some code and then I refactor it afterwards. I make sure that everything's working before I figure out what all the moving pieces are, because sometimes you get too smart for yourself and you set up a whole bunch of stuff and then you're like, oh, how does this all tie together again? So make sure that it works and then refactor it. Okay, const key in object. Users, right? users. Cool. So what does this give us access to? What is key going to be, and is key a good name? No. Why isn't key a good variable name right here? What values are going to end up inside of key from this object? The alphanumeric string, right? Exactly. So what is this inside of our users object? What could we call this? User ID. Right, exactly. So it would make more sense to say user ID in users. Because then if we do something like users at user ID, we're like, oh, okay, I get it now. If it was users at key, you'd be like, what is your code actually doing? What's happening here? Remember that, because it took me a long time to get used to this, is you're going to be part of a team. And it's important that the other members of your team can read and maintain your code. So you want to use the best possible variable names you can so that the other team members know exactly what your code is doing. I was having a discussion with Jeremy the other day, and I always thought of it as a binary situation. It was like other people understand your code or they don't understand your code. And he said it's not. There's actually a third, much more dangerous option, and that's they think they understand your code. And that's the most dangerous thing, okay, is when your coworkers think they know what your code is doing and think they can edit your code or use your code. And it's going to go very poorly, probably. Okay? So be explicit with your variable names, be explicit with your function names. Try to make your code as readable as possible, make it tell a story. Okay? Okay, so we're iterating over this, and what do we want to do with users at user ID? That's how we'd retrieve an object, right? We're looping through here. The first time through, we get ABC123. So I say, look inside the user's object at ABC123 and give me back this object. Okay? So this object has a key of email and a value, a password of email, a password, key of password, and its password. So what do we want to do with this information that we have available to us now? Okay, so we want to check, we're going to look at this user and we're going to check to see, does the email match the email? And if it does the password match the password? Right? Okay, so that we don't have to keep writing users at userid.email and stuff like that, I'm just going to store the user object in a variable called user. And I can use const inside of here, right? Shouldn't be an issue. Cool. Interestingly, we could also destructure if you wanted to, and we could pull that back off again. This is one of those areas where that aliasing of fields would come in handy, because now we'd end up with two constants called email. So this might be like the test email or the submitted email, something like that. I don't want to get too tricky with this, because I want us to focus on the nuts and bolts of the situation. So I'm just going to say we have a user that we're going to compare against. Should we console log what that user looks like? Does that sound like a good idea? Cool. Let's do this. Start the server back up. Refresh the page, and we're going to make a request to log in. Okay. So we iterated through the loop. There's two objects in it, so it should be no surprise that we printed two objects to the console. Email, password, email, password. Probably no surprises here, right? Okay. So we want to check and see if user.email equals email, right? And what if it does? If user.password equals the password that got passed in. Cool. And then we're going to log the user in. What are our other options from here? Right. So we would know that in here, right? We're inside of this if, we're saying, yes, we found a valid user. They've got an email in here. We're going to specify that we're going to return in here or something. So we then tested the password, and the passwords don't match. So we're going to passwords don't match, and we'll send some kind of message back, right? What else do we have? If we're looping through and we've got, sorry? Email's not found, right? So that would be down here. Email does not exist, right? Looked in it, couldn't find it, so we're going to send a response. Cool. We also have, so imagine these are res.send or res.render. We're just going to respond in some way. So what is another option if we get all the way down to here? We iterate over the user object, and we didn't get into here, so we never ended up inside. We didn't end up checking the password. What if somebody just submits an email that doesn't exist? We have this saying that this user, but we should probably have some kind of like final response, just in case everything falls through, just in case there's some kind of problem with our app, right? Okay, so what do we want to do if we've got our cookie parser set up? So ideally we want to log a cookie, right? And then redirect the user, right? Okay. So we'll say res.cookie, and we'll say user ID, and we'll set that to the user ID, which, hey, we called it user ID up here. That's fantastic. User ID, awesome. And then we'll do something like res.redirect to /. Okay, we'll redirect to the home page. Everything worked out correctly. We can set that user ID, and so that we can actually see the protected endpoint. How do we fix this user is not defined issue? We have to pass in a template vars, all right? So template vars equals an object of some kind, and then we're going to pass in template vars. So what is going to be our object? Presumably, if we look at our protected view, presumably we want user.email. So we're calling dot on it. So what must user be? It must be an object, right? So what if we send back the logged in user object? That is our protected endpoint after all. The only people who could see it are people who are logged in. How are we going to retrieve the logged in user so that we can send it along in our template vars? Sorry? Request.cookie. That sounds good. So we'll say const user ID equals rec.cookie. How is it that we retrieve from rec.cookie? Is it a method, or do we call rec.cookie.user ID? Is that one? Awesome. And is this how we set them? I go back and forth between this and session cookie. This is how we set our cookies, right? We use a method. Cool. Awesome. So we'll assume that by the time they got to this protected endpoint, they're finished with logging in and logging out, we should have a cookie here, right? What if we don't? What if there's no cookie? What if there's no user ID? Take them to the login page, right? res.redirect to /login. Cool. So we've handled the situation with there's no cookie set. They must not be logged in, right? Because this is what we're saying is our flag that a user is logged in. They've got a cookie. Okay. So if not user ID, then we'll redirect. Okay. So if we have a user ID, then we're going to say const user equals. We'll look inside of our users object. Users at user ID. So now we have a user. But what if we don't? What if we don't have a user? What if that user doesn't exist? What if I'm using a cookie from a previous session, or I've hacked into my cookies? Sorry? Yeah, we'll just redirect to register. Res.redirect to /register. Because they've clearly tried to log in and they don't know what's going on. Okay, otherwise, we've got our user, right? And we can pass that along. So we're saying template vars equals user. Is this going to work? Or do I need to do this? Do that? Let's find out. What's the worst thing that could happen? Right? Okay, so let's try this out, and then you can take a break. Okay, so we're going to try to log in. We're going to say Andy at 4321.ca, and fingers crossed, cannot read property user ID of undefined. Huh, I guess it wasn't expecting this. Do you think it was expecting this? Let's find out. Still can't read property user ID of undefined. So so we're hitting this. We're saying if not user, redirect, so there must be a user. Let's console log our user and restart the server. Node server, there we go. We'll go back here, refresh. There we go. Still cannot read property user ID of undefined, and we got a 500 error. Something else is happening in our code. Cannot read property user ID of undefined. I wonder if it's up here. What if we console log rec dot? Is it cookies? I have a feeling that that's what it was. Rec.cookies. Let's try that one more time. Refresh. User is not defined. This is debugging at its finest. This is what you spend all day long doing, by the way. I know it can seem like maybe the lecturer is incompetent. That's entirely possible that you have that opinion. Hey, but protected secrets. Yes, see, I told you it was going to be amazing, and it was. And you were logged in as Andy at 4321.ca. And then we have our logout button. Cool. Why don't you take a quick break, and we'll come back shortly. All right, almost everybody back. We've got a lot of stuff to cover, so we should probably jump right back in. Cool. So here's where we left off. Having the ability to log a user in, right? And see the secrets that we haven't been able to see yet. So, while we kind of wait for everybody to come back, we made an assumption here. We said, in order to see this protected endpoint, you have to have passed this. Go away. You have to have passed these tests here. There has to be. You have to have a cookie called user ID. It has to have some kind of value in it. It can't be empty string. It can't be null. It has to have some kind of value. There has to be a user in the database that matches that key. And if all of that's true, then we'll show the protected route, right? And up here, we said as you're logging in, if everything matched, set a cookie called user ID, and then redirect the user to the protected resource. So those two things mean that we must have set a cookie, right? Our user must have a cookie. So let's take a look. Inside of our application, inside of our cookies for localhost, let me make this a little bigger just so that we can look at it. There we go. How's that font size? Okay? Okay, cool. So there we go. Sure enough, we have a user ID and a value of ABC123. Okay, and that maps to Andy at 4321, ABC123. So, what is a massive security flaw with our system? It seems fine. We're able to log people in. We have methods for handling, or we can structure out methods for handling if the passwords don't match or if the email doesn't exist. But what's a huge flaw in our process here? Well, one, the user can see this, and they can see their user ID, and they can see it in plain text. And two, they can edit it. Perfect. Yep. And so logged in as this, and we refresh, and now I'm logged in as somebody else. This is what we call spoofing. This is where you pretend that you're someone else to the server. You stole somebody's cookie, or you have their user ID or something, and you've adulterated the cookies that are in your browser, and you've changed them. The users have access to everything. It's their browser. They have access to all of these things, okay? And they can freely edit them. That doesn't sound very good, does it? Well, I just demonstrated how you could switch to a different user. And imagine you were using integers like a primary key from a users table in the database. This might be 1, 2, 3, 4, 5, 6, and you could just cycle through 7. Okay, now I'm logged in as somebody else. 8, now I'm logged in as somebody else. And I can see all their posts. I can see all their friends. I can download everything they've got, right? That doesn't sound very good. That sounds like people are going to use our app, and then they're very not going to use our app. And then we're going to be looking for another job, right? See what I mean about we don't have to be security experts. We just have to know where the holes are in our system, okay? So this is a massive hole that the user can edit this. So how do we get around that? You dealt with it a little bit yesterday, right? I presume so. We need to encrypt our cookies. So you didn't deal with this. It might be this afternoon that you deal with this. Spoilers, you're going to deal with this. Okay, so let's pop into the README for a second. Okay. What is encryption? Just super quickly. What does it mean to encrypt something? Make it so that others cannot understand the message. Exactly. So we can think of encryption as a function that takes in a string and completely garbles it and gives you back the garbled message on the other side. And what makes encryption work so great is we have another function on the other side that can take in a garbled message, ungarble it, and give you back the desired, message, the ungarbled message, so that you can log a user in, or you can update some kind of state or something like that, right? But we can encrypt, we can obfuscate the message so that people don't necessarily know that this cookie is something that's so simple like this. It would be great if this was just like this, some kind of crazy random alphanumeric, and the odds of you actually hitting another valid user would be astronomical, right? Imagine this was 60 characters long and alphanumeric, so you got 36 different possibilities for each character. So you'd have 36 times 36 times 36, so 36 to the power of 60 would be the maximum number of users you could have, and the odds of someone randomly guessing someone else's cookie or their user ID or something, astronomical. Okay, so this is a way that we can kind of protect against that, because something like this where you explicitly say user ID equals this, that just says, okay, what else can I do with it? What if I change this to a 7? Does that get me somewhere? Things like that. Okay, so we need to encrypt. So encryption is a two-way process, and you'll hear about public keys and private keys. So what happens is a server or someone that you want to communicate with will give you a public key, and they'll say, this is my key, this is how you will encrypt data that you send to me. And so you'll take their key, you'll take your message, and you'll encrypt them. The great thing is the browser does this for us. Okay? If we just set it up, it says, okay, you're going to use encryption, great. Off you go. On the server side, on the recipient side, they have a private key, and the private key is what's needed to decode that message again. And so anyone, if you send this garbled message to anyone else, if they don't have the correct private key, they can't unscramble it. All of their attempts to unscramble it will lead to total garbage. Okay? So it's a way of just protecting that information. So we are going to bring in a package called cookie session. And if I want to find out about a package, what I usually do is I say npm and then the name of the package. And it takes us to npm. Have I walked you through this? Have you looked at npm? It has some fantastic things like number of weekly downloads. When you're vetting packages to use in your own applications, this is a good litmus test. If you open up a package and you see that it was downloaded 3 times last week, probably not a good idea to put that into your production server, right? This says that this thing is battle tested. It was downloaded 97,000 times in the last week. So we know that programmers somewhere are using this, and if there were any bugs or anything, hopefully they've already found it first, right? And the developers have ironed all that out. Okay, so then we're going to look at the GitHub page. npm install cookie session. That seems valid. I don't know about you, but I jump right to the meaty bits, the parts with the light gray background, because that's what we're actually interested in. Okay. So just so we can preserve this, I'm going to copy our server cookie into something, we'll call it server session. There we go. So now we have a server session. And so I don't get confused, I'm just going to close that. Here we go. So we have the exact same file, but we're going to switch this over to use sessions instead so that we don't have plain text cookies. Okay. So we need to bring in, let's actually look at this. Oh, look at that. Cookie session equals require cookie session. Okay, that tracks with most of the stuff we know so far. And since we're now using this cookie session, we no longer need to use our cookie parser, because our cookie session is going to take care of all of this for us. So we don't need to worry about setting our own cookies or anything like that. Cookie session is going to deal with it. So I can comment out our cookie parser right now, because we're not going to deal with rec.cookies anymore. Okay, so what do we need to do? App equals express. Yeah, did that. App.use, name, some keys, and a maximum age. Okay, that sounds interesting. Do we have any other examples? Ooh, look at that. App.use. So what do we know about cookie session if we say app.use? It's middleware. It's an infinity stone. Exactly. Okay, so we're setting up our session. And it came with a default name of session, but let's change that to lecture because I like it. And then you'll find out later that you can either send in an array of keys or you can send in a secret. And what it does is it takes your secret keys and it uses them to help garble that cookie that gets set in the browser. So you can make this whatever you want. This can literally be whatever you want. And you can set this up, and cookie session will use these secret keys to help to garble the message. Okay. We're now set up, believe it or not, to use cookie sessions. We've set this up as a middleware. It will sit between the request and the response. It will read the cookies as they come in and give us access to them and send things back and let us set cookies in the browser. Same as we had before, but with slightly different syntax. I can't find a really good example here. Nothing. So instead of, and we can delve into this later, instead of res.cookie, all of our session information is going to live on the request object. And the reason for that is because we're literally storing the session in the browser. Okay, so if we want to edit that session, it's part of the request object. So we want to set that up. We say rec.session because we're using, this is our particular library. And then we can say user ID equals, and then we had user ID. There we go. So we got rec.session. Perfect. And then we come down here. Everything should be fine. We should still be able to access rec.session here and get that user ID passed along. Okay, so as long as my refactor didn't break anything, we should be good to go. Server, what do I call this? Session. App is listening on port 1234. Let's go back to our server here. We'll go to /login. Okay, we're at the login screen. Just to make sure we're on an even playing field, I'm going to delete that cookie. Okay, so if I tried to go to the protected, it just redirects me to login, right? Because I failed those tests. I don't have a cookie that has a session ID or a user ID in it. Okay, let's try logging in again. Oh, nice. The refactor worked, clearly. So let's take a look at our cookie and see how we can spoof it. Oh, okay. We have a key called lecture. But hang on a second. Wait, what? Where did lecture come from? The name of the session. That's right. And guess what's inside of this, what looks like seemingly gibberish? A key of user ID and a value of ABC123. But good luck figuring out how to unscramble that, change the values, and then scramble it again. Right? Now, where do you even begin? Is it lowercase m? Is it, maybe somebody has like a capital Z there? Maybe? Probably not. So what did we solve by switching over to using encryption to protect our cookies? Spoofing, exactly. So now we have refactored, and it's a very quick refactor. You just change the res.cookies and rec.cookies to rec.session. Easy cheese. And we don't have the method anymore. It's literally just on the session, describe a prop, and feed that prop. Other than that, we can consume it immediately. When you do this later on this afternoon, this is all you're going to do is you're just going to go through and change res to rec, and move your way through. Okay? So this performs some magic for us, right? This middleware has captured all of our session data. We could have a whole bunch of other things in there. Maybe we could have like a shopping cart object or an array that has all of the things in there. Maybe we could store your friends list in there. We could have all kinds of stuff up to Chrome max cookie size. There you go. Maximum size of a cookie, 4K. Okay? So that's how much stuff we can jam into that cookie if we want. And it all lives inside the user's browser. And what happens if we open another tab? Is this going to come along for the ride? We still have lecture in there. But if we close all of this and then open Chrome again, hopefully, I'm just experimenting here. We'll close 1, 2, 3, 4. What? But I was just logged in. Whew, so glad that worked. Okay, I was just logged in. What? What? Gone. By default, the default nature of sessions is they last for the length of the browser. So in other words, you can't have somebody, you close Chrome on your system, somebody comes over, sees your computer's unlocked, open Chrome, and they get into your bank account. No. By default, all of our session cookies are immediately deleted by the browser. So we have to start a whole new session again. This is for security. Okay? The other thing we can do is, if we have our app.post to/logout, and we get our rec and our res, all we have to do is say rec.session equals null. Res.redirect to login. There we go. So that'll do the same thing, and I can demonstrate that. We will keep this open for a second. We'll log in. We log in, we see that we set our lecture here. I'm going to scroll down, our lecture cookie. We're going to log out, and cannot post to log. Oh. See, we got the request. We just got a 404. When in doubt, restart the server. Okay, let's try that again. We've got all of our cookies here. We hit log out, and we're back, and the session is now null. It's deleted the cookie from the browser. So this is how we take care of this. Okay? Yes. The lecture.sig did not, and I'm not 100%. I'm assuming that's short for signature. We can look into what it's doing on our behalf, but it's probably using this to somehow validate this. And yes, it didn't follow us along, but we were still able to log in. So we'd have to look into the documentation to see what it's actually doing if you're interested. Okay? I don't have an answer for that off the top of my head. Okay, so we dealt with one of the three main pillars that we want to deal with today, and we are 95 minutes into our lecture. Okay? Fantastic. So we have another major security flaw in our application, and it's right here on the page. Specifically line 13 and line 17. Plain text passwords. Now you might be thinking, this is really no crap. Like, I didn't pay all this money to come to web development bootcamp so you could tell me not to store passwords in plain text. Nobody would store passwords in plain text, would they? Surely not. Surely not. There's probably not a repo that's full of every single plain text offender somewhere that has 5,654 lines in it. Surely not. But look, co.uk, sure. I mean, they're probably pretty lax over there. .com, yeah. You know, .net. I mean, we're never going to find like a .ca website in here, would we? No, not the Stratford Festival. Oh, but, okay, so regular web developers, right? We're not going to see, like, our government do, oh. And more than once. Okay, this seems like no crap, but this happens every day. Plain text passwords, they're stored, and you know how people find out about this? This is not the result of hacking necessarily. check this out. There's a very quick way to tell if the server is storing your password. If they email you your password, they're storing your password. Okay? That's where this list comes from. It's people going, what the crap? You're storing my password in plain text? So we can't store passwords in plain text. Just don't do it. It's not even an option. This is horrendously bad. Our ideal situation is, as a dev, as the person who's running the web server, I have literally no idea what your password is. You typed it into some form, and then I ran some kind of algorithm against it, and I tested to see if it was the correct password, and then I logged you in. But I have absolutely no idea what your password is. As soon as I used that form data, I threw the password away. I'm not logging that anywhere. Okay. So does anyone have any ideas about how we can get around storing plain text passwords? Similar sort of idea if we jump back to here, but we're going to do something called hashing. And hashing obfuscates the message again. It will take plain text, run it through an algorithm, and spit out what looks like garbage. It's alphanumeric gibberish, right? The thing about hashing is that it is a one-way process. You cannot, in theory, for good, well-designed systems, you cannot take a hash and reverse engineer a password back out of it. That will not work. It's a one-way process only. And to kind of illustrate that, let's just create a little super simple hash function that takes in. I just want to demonstrate why this is different from, because we all have experience with encryption, right? When we were kids, you had like secret messages with your friends maybe where it was like A equals 1 and B equals 2, and then you slide it over on the desk so the teacher doesn't notice, and then even if they do read it, it's just a bunch of ones and zeros or something, right? They have no idea. But your friend has the way of turning that back into a real message that says, yeah, meet at the playground at recess? Yeah. Right? Okay. Anyway. But hashing is by design is a one-way process, and that might be a little harder to wrap your head around. So let's say that we're going to have a function that takes in a string. And what we're going to do is we're going to iterate over this string, and we're going to turn each character, iterate over the string, turn each character into a number. So let's say that we have the string, our string is ABC. So if we were going to encode this, if we're going to encrypt it, we would turn it into something like encrypted string equals 1, 2, 3, because they're the first, it's letter 1, letter 2, letter 3, right? So we say 1, 2, 3. Or maybe we're using a reverse algorithm. We got super smart and we just said A equals Z, B equals X, all the way up to M equals N, and then it loops around again. Great. But at least we can get this back again. But if we were going, so this would be encryption. But we want to hash this. So we want to take this original string, and what we're going to do is we're going to turn each character into a number, but instead, we're going to say that our hash string equals, and we're going to add them together. We're going to say A is a value of 1, B is a value of 2, C is a value of 3. So our new one equals 6. So we took in a string, and we're going to return the number 6. What does 6 tell you? It tells you that the total value of these added up to 6. But that means that it could have been 6. It could have been AAAA. It could have been F. It could have been BBB. It could have been EA. It could be AE, right? You see how this is, we ran it through an algorithm and got back a hashed value that we could compare against, because next time when you submit, this is a terrible hash, by the way. Use someone else's hash. Don't write your own hashes. We would compare that we would hash the value of whatever the password that comes in, and we'll compare it against this one, and we'll say, yes, those went through the algorithm and it came out to the same amount. But if someone downloads your database, they get in, they download, all they see is a whole bunch of just random numbers under the password field. And they're no further ahead to getting your users in, like more of your users' information or using that password, because we all use the same password on pretty much every single website, right? Even though we're web developers. Yeah. So if they get your password in one place, they can use it somewhere else. And there's actually websites that you can go to and type in your passwords, and it will tell you whether that already exists in some table somewhere that some hacker has built. Or it'll tell you that your password's totally fine and no one has found that anywhere. But hackers love to share information and they love to sell information because that's how they make their money. So people would love to buy all these passwords, so we're going to hash it. But we're going to use another tool. Yeah, normally, and you'll actually use bcrypt, but I have a terrible time getting bcrypt to run on my Mac. Inside of Vagrant on a Linux machine, great, no problem. Running in a Mac, I get, notice how it's pumpkin all the time now? Never-ending pumpkin mulch, nifty pumpkin, neurotic pumpkin murderer, nocturne. Has anyone shown you this on NPM? Oh, I'm the first one. Nice. Nitrogen pumpkin mulch. Their NPM says that NPM doesn't actually stand for anything. Everybody says like, oh, it's the node package manager. And they're like, no, it's nothing. It's nebulous pumpkin moons. It's neurotic pumpkin murderer. It's ninja pumpkin mutants. I like that. That's fantastic. It's all pumpkin this month because, Halloween. Okay, anyway, bcrypt 590,000 times in the last week. That sounds pretty legit. Here I can link to the GitHub repo, and I can also see basic usage. npm install bcrypt.bcrypt.js. Well, that sounds pretty simple. Let's jump over to our terminal, and we're going to, that's not what I want. Command V, there you go. Oh, that went weird. Okay. I'm just going to type it myself. How about that? npm I bcrypt.js. Is anyone showing you these aliases? Did they show you all of the aliases? No? Cool. Man, I get to do so much awesome stuff with you today. Okay, so obviously we can use I as a short form for install. How do we spell install? How do we spell install? I can never remember. Is it like that? This was such a common misspelling that NPM actually aliased it to mean install because developers just mistype things. So this is a valid alias for install. Okay, so we now have this bcrypt package. Let's just play with bcrypt for a sec. So we're going to jump into here, and we're going to say, what is it you want? Oh, it's this require thing again. That's pretty simple. Okay, now we've got bcrypt. Awesome. And then configuration. This is for browser and stuff. Using it synchronously. Do we want to use it synchronously? Probably not. Let's use it so we can see that we can compare hashes, and presumably we can generate hashes. But it also expects another argument. It expects the string that you're going to encode, that you're going to hash, but it also expects a salt. Does anybody know what a salt is? So the answer for Calgary was it's a random string. Generally it is. You can actually specify salts if you want to, but generally it's a randomly generated string, and it's attached to the password before the password gets hashed. So let's say we plug in a password of password, and so what it'll do is it will add on the salt and then hash all of that. And the reason for this is it protects against attacks from dictionary tables or rainbow tables. And you can look up rainbow tables. They're really neat to kind of stare at It's an interesting idea. Some of these actually arrange it in a rainbow. But this doesn't really mean anything, and I tried to read through it doesn't mean anything to me. I tried to read through the Wikipedia article last night, and I was like, yeah, no, okay. So suffice it to say, a rainbow table is a bunch of dictionary words, like normal words that people would use, like password and 1, 2, 3, 4 and things like that, that have been hashed through standard algorithms. So in other words, some hacker somewhere has spent all of the time to pre-compile all of these strings into hashes so that when they download your database, when they get into your network, all they have to do is take your hashes and compare them against the table. And if they get any hits, they know what the string was that generated that hash. And then they've got your user's password. So if you had something like password or something like that, then they could easily get that. But if you salt it, it makes it much, much, much harder because now it's password plus some random alphanumeric string, and then that got hashed together. And so the other thing that they want is they actually want like a number. You can actually pass in an integer into here. And what this says is if you passed in something like 10, it means I want you to hash the value. I want you to attach a salt to it and hash it. Then I want you to take that value and hash it again. Then I want you to take that value and hash it again and again and again and again. And the more often you do that, the more secure it's going to be. But the longer it takes. And let's demonstrate that. So we've already got our require. Let's just bring these in and take a look at this. We're running short on time, so we'll just use the synchronous version. Normally I wanted to illustrate the fact that, maybe I can do it here. There we go. It either accepts a callback as a third argument, or it returns a promise. It's up to you about how you want to consume it. So if you're doing this asynchronously, you can call .then on it, or you could pass in a callback as a third argument. It's up to you. And this is what we talked about last Thursday. Is generally the way you deal with promises is from some other library, and some of them are going to give you the option. When you deal with jQuery next week, they also give you the option. How you want to do it, what flavor works for you. Okay? So let's see what happens when we pass in password, and we'll actually get rid of this gen salt, because you don't necessarily have to gen it. You can actually just pass, let's say 5. And let's do const input equals password. That way we can do this dynamically. We'll pass this in as our input. So you've got a new user that's registered. They gave you a password. You're going to hash it before you store it in your database, in your users object. Okay. And now let's console log the input, and then we'll console log the hash, and we'll see what it generates. Clear node hash. Promise pending. Great, because I took this off. There we go. Hey, that's what I meant to show you. It's a promise. We could call .then on it. Okay. So it turned PASSWORD into a 60-character alphanumeric string with some special symbols in there. And if we run it again and again and again, we'll see that we get different values, and the reason why is because it's using a different salt every time. It actually encodes the salt as part of the hash. That way it knows how to use it to unscramble it at the end. Okay, so let's find out what happens. So that was 5. Let's make it 50 and see what happens. I don't actually know when this is going to end. Some people have said that if you set it to 1,000, it'll take 24 hours to generate the hash. So this is kind of this is where those, when I said the hash tables are pre-compiled, is the hackers have traded time and they've stored all those. So they just set it running and generating all these hashes so that when they do want to hack, all they have to do is just compare it against the table that's already got hashed in there. I have no idea when this is going to end. So we'll kill that. So usually you'll see something like 10, which takes about that long. And so this is what we would actually store in the database. Okay? So Yeah. Oh, so let's take a look at this. So our salt can either be, we see down here that our salt length to generate or salt to use defaults to 10. So what we're saying is generate a salt that's 10 long and use that. So salt length. So we're not actually using this as a salt. If we did something like this, then we would actually be using that as a salt. And let's see what happens if we do that. So there's our new salt. Throw error, invalid salt version AB. It didn't like that at all. So let's just stick with numbers. Okay. So hashed password equals what I copied from the thing. Okay, so we're able to hash these passwords, right? We get this back and forth. Actually, we have our hash up here. We're already storing that. So we're going to console log that. So this is all well and good. We can register a new user. We can hash their password securely so that we have no idea what the password is. It'll just be some random alphanumeric string. But what happens when it comes time to log them in again? bcrypt gives us a compare. And synchronously, if you drop the sync, then you get the callback promise thing as before. So this takes in a plain text and a hash, and it will tell you whether it's true or not. Awesome. So const result equals bcrypt dot compare sync. There we go. And we're going to pass in the string password and our hashed value. And then we'll console log the result. Okay, so it's going to compare synchronously. So in other words, it's going to stop the application and continue running this for however long it takes. It's going to compare this string against this hashed value. And then we're going to output the result. So we took password, we turned it into a hash, then we compared it again, and we got back true. Okay, so what if I tried to log in with ABC123? False. And it's just that easy. That replaces our looking up and saying, does password equal password? Because we won't be able to do this anymore because one of these is plain text and one would be the hashed one that we're storing in the database now. So we need to use this function to now compare those two values. And we can put this, we can actually just copy this right into this instead. So instead of comparing the plain text password with the plain text one we were storing, we're going to hash it, the input, and then compare that against the hashed value. And then we know whether we can log the user in or not. Okay? So 11:55, we've solved two of the problems. We solved the ability of users to edit those cookies and spoof someone else's session. And we're no longer storing plain text passwords, so we won't end up on this list, hopefully, to our shame. We have one more thing that we need to deal with, and it's not, may or may not be super obvious. I'm leaning towards not. And it has to do with one of the things that we talked about right at the beginning. Yes, we need to use HTTPS. HTTP is unencrypted by default. Hence the S stands for secure. So even if we take all these measures in the world and we say we're going to encrypt we're going to hash the passwords, we're going to encrypt the sessions, we're going to do this stuff, any communication that we make over an open channel, like over a Wi-Fi network or in a Starbucks network, is going to be plain text. Everything we send over. So when I submit my form, it's going to have my username and password in it. And anyone who intercepts that message sees it all in plain text. Okay? This is how person-in-the-middle attacks work. What you would do is you would go into, I'm not suggesting this, but this is how it works. You go into somewhere with a public Wi-Fi, you connect to that public Wi-Fi, and then you turn your computer into a router. And you start broadcasting and saying, hey, anybody wants to connect to me, I'm Starbucks super free Wi-Fi. Connect to me. And then you have users connect to you, and you just proxy them, and you say, okay, you connected to me, and I'll connect you to Facebook. Sure. Oh, you want to send that to me in plain text? Okay, I'll strip that off, and I'll send your message along. Great. And then Facebook comes back, and I get to see the messages from Facebook too, because that's also HTTP. Great. And so you just sit in between, and you act as a proxy, and you can get everyone's information off of there. So how do we handle making it so that someone can't read what we send over the wire? We have to encrypt it. We have to get the public key from google.com or facebook.com or youtube.com. We get their public key, and we switch over to HTTPS. And we will encrypt all of the data using that public key so that it's just random garbage that gets sent out to YouTube. And then YouTube on the other side uses their private key to unscramble the garbage and get your username and password and then do their own comparison against their hashed values. But someone who's sitting in the middle and proxying, all they're getting is just random stuff. They have no idea. They can't get any information out of it. Okay. So this, and if you want to set this up for your website, you have to get like an SSL or a TLS certificate. And you can tell if a website has it, because it'll show, oh, come on you. Where'd you go now? There we go. It'll show a lock in the corner. And that's how it'll tell you that it's actually there. And if we can show that by going to our page, and our page lacks that lock there because it's hidden from us. But what value is actually in here? If you don't specify, your browser automatically attaches HTTP onto the beginning of the message, onto the beginning of the request. So this is being sent over plain text. And even though we're doing all these other things to protect our users, anyone who's sitting in the middle can read those messages, can see everything that's going on. Okay. So these are the three, hopefully these are the big takeaways from here, is encrypt the cookies so that users can't spoof other users. Hash passwords, and use HTTPS, okay, to encrypt your user data. Because nothing shakes a user more than finding out that a website got hacked. You're less likely to use that website. You're less likely to give them your credit card. You're less likely to buy a premium membership, right? And this is how we get paid. This is how we make money. So like I said, you don't need to be a security expert. Just keep those three things in mind. And we've got one last little talking point here. We have exactly no time left. So when do we want to use all these things? So plain text cookies, almost never. Almost never. It might be something like a user has a default language selection or something innocuous. Maybe you're putting together a shopping cart for a user that hasn't logged in yet. In the event that they log in or join your site, you can then turn that into a real shopping cart object, and they can continue on with their transaction. Maybe some Google Analytics or something, or you want to say like how many times they've visited the page or something like that. Something innocuous that if they get their hands on it and they edit it, it doesn't really do anything to your system. Okay, so they changed their language selection from EN to FR. Well, now the page is just going to render in French. There's nothing really terrible about that. Encrypted cookies. Do this by default. In other words, use some kind of session thing like cookie session. And you can get away with just storing something like an ID, because you can use that to look up any values that you want in your database or on your server or something like that. So you don't need to store a ton of information in the user's browser, even though you can up to 4K. Just store something that you can use to reference information on the server, just as a way of remembering who that user was. Okay. And we didn't really talk about this, but cookie session stores everything in the browser, right? We accessed rec.session. You can also do that on the server side instead. And for all intents and purposes, for us, it would be exactly the same. They would just store like a session ID that on the session on the server would then take that ID and look it up and get all their information back again. The advantage to this is that you can store, there's no limit to how much you can store because you're on the server now. And it's more secure because it's guaranteed that the user only has a session ID. They don't have their user ID. They don't have a username. They don't have a password. They don't have anything else. But it takes a lot more time to set up. There's a lot more overhead. It's not as simple as just bringing it in and calling rec.session. If you need to store lots of session data, if your session data frequently changes, like you wouldn't want to have to keep changing that cookie all the time. Or if you want the ability to invalidate a specific user's session in between requests. Because we can't invalidate a user's session until they give us a request. And then we could say, okay, log you out. Or something like that, right? But until then, they're walking around with this cookie in their browser, right? Here, we could invalidate the cookie on the server side. We could just say, hey, that cookie is no longer valid. We're logging that user out. It's done. And then we don't have to wait for them to come back again. They'll find out when they try to log in again that their cookie is no longer valid. Any questions at all about security, cookies, HTTP authentication, bcrypt hashing? Yes. Could we do a forced logout by changing it, the user ID, as a token? So like a JSON web token or something like that?
Well, like even if it was just still a random string.
Yeah.
As long as we're making sure it has something in place so they don't collide when we change them.
Yes.
We just change the user ID, and then next time the token does the lookup, it's like, oh yeah, this doesn't exist anymore.
Yeah, we could actually just change if you wanted to do something like that. So you're giving them like a proxy thing instead. You're not saying it's the user ID, it's some random, you're making your own key, your own token.
It'll go
Yeah.
to the user ID and see which one has a token that matches.
Yes.
Change that.
Yeah, so that would work. So for Calgary, the suggestion was that inside of here, we could have like a token key, which is where we come up with a randomly generated string. And so we would just manually compare this against whatever the value came back from the cookie. And we could also just say, this is now null, so it just won't match anything. And that's a way that we could invalidate it. But again, it's coming back to why do we bring packages in to begin with, is so that we don't have to reinvent the wheel, right? If we can just call, I'm not saying this is a bad idea, and you might want to do that in an application. But generally, we just want to have the ability to say rec.session. And it just takes care of everything for us and deals with that. Any other questions? Was there a hand up over there? Calgary, how you doing? You've been very quiet. The cookie session file? Key one. The cookie, the actual session one? Okay, let's take a look at which section of this was it? Down here? Oh, right here. Right here. So we have key 1 and key 2. The other option for this is you can pass in a secret string if you don't want to pass in the keys. We can actually see that in cookie session. So here we go. Keys. The list of keys to use to sign and verify the cookie values. Set cookies are always signed with keys at 0. So in other words, this one doesn't need to be there. While the other keys are valid for verification, allowing for key rotation. So you can get away with just one key, and it will just rotate through. Or a string that will be used as a single key if keys is not provided. So this is like an either or. Either you can do that, or you can do that. It depends on what you want to do, what your organization has decided, whatever's going on. And generally, you wouldn't store this and then post it to GitHub. You would store this in like an environment variable or something, so it's dynamically loaded at runtime. So yeah, so setting it up, you can later on today or whenever you get into using this, you can literally just do what I did, which is copy and paste this code, and it will work for your purposes. Okay. Any other questions? Oh, what the key does? Oh, because it is using, what did it say about keys? To sign and verify the cookie values. So it's probably using that like some kind of salt. It's concatenating that together, and so it's a unique value. That's why it's a secret. So it's a unique value to help you verify that the session or the cookie is valid. Anything? Did we touch on everything that we wanted to touch on? HTTP and cookies. Register a user with email and password. Actually, we logged in a user. I didn't think I needed to go through registering. Store the passwords. Alwaysy. Hash. Encrypt cookies. Use HTTP secure. And then we talked very, very briefly about server-side sessions. They're not very popular. Cool. I can tell from the applause in the other room that it must be 12:08. Awesome. Any other questions before I let you go? Yes, absolutely. I'll send the lecture notes and everything out very shortly because I have to go to work. Thank you very much for your time. Thank you, Calgary.